to do a quick review of limits. Now, you guys spent time with these in math analysis or the double up class or pre-calc, depending on where you came from. So it should be a review and fairly familiar. So take notes on what you need to as we go through this, and then write down any questions you have for class tomorrow. So as you know, a limit is the study of change in calculus, and it allows you to describe a function's behavior different than just plugging in a value. So it's needed when we get to derivatives and integrals later in the year, and it allows you to look at what value is a function approaching as you reach a certain input. So this is very different than plugging in an input and what is your output like we did at the beginning of the year. Sometimes a function doesn't have a limit, or sometimes it will never actually reach the limit value, different to when you plug in an input, you always get an output. So evaluating functions with inputs and outputs and limits are very different. So this is the standard form of a limit. What it tells you is the limit of some function as x approaches a particular value from either side, left or right, it equals a number L. So just jot that down, but we're going to be filling in the f of x with the function and the c with the number that we're looking for the limit of. Okay, so in general terms, you definitely want to write this down. A limit is a number to which the output of a function becomes closer and closer to as the input comes closer and closer to a given value. So as the x value approaches a certain number, what is happening to your output of your function? What value is it approaching? It can either be positive, negative, 0, infinite, or non-existent. And throughout the unit, we're going to look at situations of each of these. So again, make sure you write this down, and in general terms, you can tell me what a limit is. So we're going to get into this more later in the unit, but the function must approach the same value from both sides. So if you're looking at a value of 2, the function must approach that limit from the left side and the right side. If it doesn't, then we start to look at limits of left-hand side and right-hand side, and we'll look at that later in the unit. Okay, so what is the application of a limit? You guys hear the word limit all the time. Speed limit, wrestler's weight limit, limit of one's endurance, stretching a spring to its limit before it breaks. Okay, this all suggests that a limit is a bound. Sometimes it may not be reached, other times it may be reached or exceeded. So think about a spring that has a certain weight limit. How far can it stretch before it breaks? This would be the limit of the spring's stretch as the weight approaches, say, a weight of 10. So how long will the spring get before it reaches its limit and breaks? There's also a lot of other applications of limits, and as we progress through the unit and get more comfortable with taking limits, we'll look at application problems. Okay, so for the limit, from both sides, our answers, again, could be positive, negative, 0, infinite, or does not exist. And we're going to look at situations of all of this throughout the unit. So in order to find the limit, you want to go through with some strategies. If you plug in the value x that the limit is approaching and you get 0, then you need to try some different things. One option is to factor and cancel out any factors. Another idea is to rationalize, and then the last option could be to graph as well. So let's take a look at some basic limits that should just kind of refresh your memory about what you did in math analysis or the double up class or pre-calc. Okay, so say I gave you this problem. Say you have, and you want to write this down in your notes, the limit as x approaches 1 of x squared plus 1. Now this limit is pretty easy because you can solve it algebraically by just plugging in 1 and seeing what value it approaches. So if you plug in 1, you get 1 squared plus 1 So your answer is 2. If you looked at this graphically, it's a quadratic that crosses at 0, 1, so it's something like this. And as x approaches this point right there, you will see that your output is 2 as you come down from both sides. On both sides, as you approach x, as you approach an x of 1, you get an output of 2. Okay. What about this one? The limit as x approaches 2 of the function 3. Now the function 3 is just a horizontal line at y equals 3. Whoops. At y equals 3. So as x approaches 2 from the left-hand side and the right-hand side, what is your output? Your output is always 3. So this limit, as x approaches 2 of the function 3, is 3. One last one to look at. The limit as x approaches 2 of x squared plus 2x minus 3. Now you could solve this graphically. You know it's a parabola. You can plug it into your calculator and see what y value it's approaching as you get to 2 from the left-hand side and the right-hand side. But since if you plug this in, you don't get a 0 in the denominator, there aren't any errors, you can just solve this algebraically, doing 2 squared plus 2x minus 3. Oops, sorry, that shouldn't be 2x, that should be 2 times 2. 4 plus 4 minus 3. Okay, so our limit for this function is 5. Okay, so limits are obviously going to get trickier as factoring is required, zeros in your denominators, and radicals get involved. But for right now, if you can plug in the value and you don't get a 0 in your denominator, there's no radicals, you can just solve it algebraically. So tomorrow in class, we will start to look at more complicated ones. But for now, just remember that the limit must approach the same value from both sides. And later down the road, we'll look at what happens if the left-hand side and the right-hand side don't match. Okay, so write down any questions that you might have and ask me tomorrow in class.